Failure of a drilling rig mast structure. Summary. A drilling rig that was used for the exploration of gaseous fuels was inspected. During its operation, the rig mast suddenly collapsed and the structure got twisted from the middle. The failure investigation was carried out to determine the probable causes of failure in the rig. Estimation of mechanical properties. Optical microscopic analysis along with scanning electron microscopy examinations were necessary supplements to this investigation. Detailed stress analysis of the structure for different conditions of loads and anchors was examined. Investigations. Visual examination and preliminary findings. Visual examination of the failed mast structure was carried out and it revealed the following. I. The maximum damage and bending, twisting were localized near to the middle portion of the mast structure, Fig. 2. E. Plastic deformation in the form of bending and twisting of the failed structure was evident as shown in Fig. 3. E. A number of cracks open to the surface of various magnitudes and direction were present at many of the welded joints away from the damaged locations of the mast structure, Fig. 4. It is possible that appropriate non-destructive testing was not carried out during its scheduled inspection. IV. There was inadequate reporting of previous NDT inspections. V. The stress recordograph was not functioning properly during the event of failure. Results and discussion. Metallographic analysis of the damaged and undamaged region revealed a microstructure consisting of pearlite and Widmanstätten ferrite, Fig. 5. There was no abnormal material degradation in the damaged location of the failed mast structure. A thorough examination of the fracture surfaces, Fig. 6, revealed a texture indicative of cleavage-type cracking with riverline patterns at places along with ductile voids around the vicinity. The crack initiation zone was observed in Fig. 6b. It can be concluded from the SEM image that the failure was due to the application of the stress that exceeded the strength of the part. Fig. 5. Microstructures of the undamaged part and B. Damaged part of the mast structure. Fig. 3. Deformed and twisted angle near the middle portion of the structure. Fig. 4. Magnetic particle examination revealed the presence of any cracks in the weld joints at many locations of the undamaged part of the mast structure. 5 different configurations have been analyzed to examine the possibility of failure of any member of the structure or anchoring cable. All the configurations have been analyzed for 160-ton load on the mast structure. Case 1. The complete structure before failure with all the anchored cables in positions and 160-ton load on the structure. Case 2. The complete structure without one anchored cable connecting top of the mast and anchoring point. Case 3. The complete structure without one anchored cable connecting top of the mast and anchoring point. Case 4. The complete structure without one anchored cable connecting the middle of the mast and anchoring point. Case 5. The complete structure without an anchor cable connecting the middle of the mast and one anchoring cable. Conclusions. Based on the NDINGS of this investigation, it is concluded that non-functioning recordometer did not provide adequate warning that the load applied to the mast was applied at the dangerous levels. This ultimately led to rapid increase in operating load. One or more of the cables or the anchoring points did not have SUFC and strength to withstand the rapid increase in operating load exerted due to the sudden additional pull. One or two anchoring cables at the top failed RST. Thereafter, stress between the lower and upper parts of the mast structure was beyond the yield strength and mast deformed plastically, failing under its own weight.
Subscribe to my channel. And also press this bell icon, so you never miss any new updates, cause whenever we upload new video you will get a notification on your phone.